Hello everybody and welcome to today's lesson on using congruent triangles. Our objective for the day is we will be able to use congruent triangles to prove that corresponding parts are congruent. In our last few lessons, we discussed how to prove that two triangles are congruent. But when two triangles are stated to be congruent, what can be concluded from that? How can we use this information to prove more things? Well, let's look at the following example. Triangle PQR is congruent to triangle PLM. If these two triangles are congruent, then all of their corresponding parts have to be congruent as well. Let's think this through. For example, angle R, which is right here, has to be congruent to angle M. So the two triangles are congruent. Therefore, angle R has to be congruent to angle M. How about angle Q? Angle Q has to be congruent to angle L. So therefore, angle Q has to be congruent to angle L. But not just angles. What about sides? What about the side PQ? The side PQ, which is this one, has to be congruent to the side PL. Or we can write, therefore, PQ is congruent to PL. And a lot of other things too. Basically, all angles that are in corresponding positions have to be congruent, and the same goes for all the sides. In other words, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Let's mark the beginning letters. And that is the abbreviation that I want you to write down and remember. CPCTC stands for corresponding parts of congruent triangles are congruent. And this is a very important principle that we need to remember now for the rest of this lesson and going forward. Let's look at a couple of examples and see how we can apply CPCTC. Example 1. Prove the base angles theorem. We have given that side HI is congruent to side HK and HJ bisects IK. And we're supposed to prove that angle I is congruent to angle K. Well, first of all, as always, we have the given information, and we're going to put that given information, the statement, and the reason into our T-chart for our proof. HI is congruent to HK. HJ bisects IK. And the reason is this was given. So what does it mean again that a segment gets bisected? The segment IK gets bisected. That means that it gets cut into two congruent segments. The bisector cuts the segment in the middle and creates two segments that are congruent. So let's start marking things here in our diagram. First of all, HI is congruent to HK. That was given. And if IK gets bisected by HJ, that means that IJ and JK are also congruent. And that's going to be our next statement. IJ is congruent to KJ. And what is the reason for that? The reason is that this is the definition of bisecting. These two segments get created by bisecting IK. What else can we see from our diagram? We have this side HJ that is the side of both triangles. And HJ is of course congruent to itself, and that's based on the reflexive property. HJ is congruent to HJ, the reason being the reflexive property. So let's see what we have so far. If we just look at one triangle for now, what have we found? We have found that this side is congruent to another side, this side, and this side. We have found three sides that are congruent to the corresponding sides of the other triangle. So we can say that triangle HIJ is congruent to, and now we have to follow the same sequence. If we went from H to I and to J, we went over the side that was marked with one congruent mark, and then over the side with two congruent mark. So our congruent triangle is HKJ. And the reason these two triangles are congruent is our side, side, side congruence postulate. But are we done? No, we were supposed to prove that angle I is congruent to angle K. Well, let's look where angle I and K are. Angle I is here in the middle of our first triangle. Angle K is in the middle of our second. So those two angles are corresponding angles. So we can say angle I is congruent to angle K. Angle I being this one, angle K being this one in our diagram. And the reason why is that they are corresponding parts. They are in the same position of two triangles that are congruent, and corresponding parts of congruent triangles are congruent. CPCTC. That's what we wanted to find out, and that's where CPCTC helped us for the final proof. Let's look at another example. Given our angle B is congruent to angle E, side FE is congruent to side BC, and FE is also parallel to BC. So let's first of all mark those things in our diagram and put the statements down. Angle B is congruent to angle E. FE is congruent to BC, but FE is also parallel to BC, so we are also going to make a parallel mark like an arrow on FE and BC. Now let's write these things down in our statement column. And all these things we know because they were given. Now what else can we find out about these two triangles? We have two parallel sides, BC and FE, and they seem to be crossed by a transversal. Look how that makes a nice Z shape. And when we have parallel lines being crossed by transversals, remember we create all sorts of special angle relationships. And the one that's important for us to note here is that these two angles, angle BCA and angle EFD, are congruent because they are alternate interior angles. See that they're both on the inside of the parallel lines and on opposite sides of the transversal. We have to be a little bit specific with the angle names. That's why we couldn't just take one letter. Angle BCF is congruent to angle EFD. And the reason is they are alternate interior angles. Time to stop again and see how many parts of the triangles have we found congruent. Looking at our top triangle, we have found an angle this side and an angle that are congruent to the corresponding parts of the other triangle. And we don't even have to notice that these other parts we don't have. We can't cross more than one x, remember, so we have to go from A to S to A. ASA is the reason why those two triangles, triangle BCA and triangle EFD, are congruent. Triangle BCA is congruent to triangle EFD, and the reason is the angle side angle congruence postulate. Again, let's see what we were actually supposed to prove. We were supposed to prove that angle A is congruent to angle D. So far we hadn't been able to find anything out about angle A and angle D being these two angles here. But since the triangles are congruent and these angles are in corresponding positions, we can say that angle A is congruent to angle D. The reason being corresponding parts of congruent triangles are congruent. On to our next example. Given R that TM is congruent to MR and JM is perpendicular to TR. Yes, remember that sign that looks like an upside down T means those two lines are perpendicular. Now let's first fill out our statements. TM is congruent to MR and JM is perpendicular to TR, and that information was given. Now what does it mean that two lines are perpendicular? What does that really help us? Perpendicular means that they intersect at a right angle. Remember? These two lines intersect at a right angle. That means they have given us the angle of 90 degrees. Very good. Then let's mark what we actually have in our diagram. TM is congruent to MR. JM is perpendicular to TR, and that means that this is a right angle, and so is this. So angles JMT and JMR are both right angles. And the reason for that is that this is the definition of perpendicular. Alright, let's keep looking. What else can we say? And again, we have a side, in this case JM, which is the side that's part of both triangles, and that side is of course congruent to itself. JM is congruent to JM, and this is because of the reflexive property. So let's take a look again what we have determined. Looking at one triangle at a time, we have this side, this angle, and this side that have a partner that's congruent to them. So we can say that triangle JMT is congruent to triangle JMR, and that's because of the side angle side congruence postulate. But what were we supposed to prove here? We were supposed to prove that the side JT is congruent to the side JR. Let's look at where they are respectively in their triangle. JT is this side and JR is this side. They are definitely corresponding sides. So it is proven that JT is congruent to JR, and yet again we were able to prove this saying that corresponding parts of congruent triangles are congruent. Now at this point you have probably seen the pattern already, right? So in this example we went from our side angle side congruence postulate to CPCTC. In the previous example we went from the angle side angle congruence postulate to CPCTC, and in the very first one we went from our side side congruence postulate to CPCTC. So the one thing that I want you to go back into your notes and in your side margin write down and be sure to always remember is that we always use CPCTC after we have determined two triangles are congruent. First we need to prove that the triangles are congruent, and then we use CPCTC. Write this down, circle it, put stars around it, and highlight it. This is very important to remember. Okay, for your summary, I want you to spend a moment to describe how you use the congruence theorems or postulates and CPCTC to prove two corresponding parts are congruent. That's it for today, and I will see you in class.